All right, let's dive into a topic that sounds like it's straight out of a movie, but is actually becoming a reality. Today, we're going to break down a revolution in computing that's poised to literally reshape our world. So, let's get right into it.
Just let that sink in for a second. Thousands of years of work done in the time it takes to snap your fingers. We're not just talking about a slightly faster processor here. This is a totally new, mind-bending way to compute, and it's called quantum computing.
So, to really get a handle on where we're going, we've got to first understand where we are right now. Let's start with the absolute basics, the foundation of every single digital gadget you own.
Yep, that's really it. Your phone, your laptop, the entire internet, it's all built on trillions and trillions of these tiny little light switches, just flipping between 0 and 1, off and on. It's an amazing system for sure, but it has its limits.
And this is where we take a giant leap into the quantum realm. See, instead of those simple on or off bits, quantum computers use something way stranger and way more powerful. They use something called the qubit.
See that part that says or both? That's everything. A normal bit is definite. It's either a 1 or it's a 0. But a qubit? It can be a 0, a 1, or it can exist in some weird combination of both at the exact same time. This is the secret sauce, the magic trick that gives it all its power.
Okay, I know what you're thinking. Both at the same time? It kind of breaks your brain a little, right? It goes against all our everyday logic. But don't worry, there's a really simple way to picture what's going on.
So to get how something can be two things at once, let's just forget about computers for a second and think about something super simple, a coin.
This really nails it, right? A coin just sitting on a table, that's a definite answer. Heads or tails, 0 or 1. But when you spin that coin, while it's in the air, it's just a blur of possibilities. It's not really heads or tails, it's kind of both. Well, that spinning state is what scientists call superposition, and that's the heart and soul of the qubit.
Okay, so qubits can be in multiple states at once. Cool, but why does that make them so unbelievably fast? Well, let's use another analogy to see this incredible power in action. Here's the key difference. A normal computer is like sending one person into a gigantic maze. They have to try one path, hit a dead end, backtrack all the way, and then try another path. It's methodical, but it is so slow. A quantum computer, because its qubits are exploring all the possibilities at once, is like sending 1,000 people into that maze at the exact same time to check every single path simultaneously.
Exactly. The quantum computer finds the solution almost instantly because it doesn't have to go down each path one by one. It gets to see all of them at once.
So this all sounds incredible in theory, but what does it actually mean for us, here in the real world? Why does solving a maze faster even matter? Well, it turns out that many of the world's biggest challenges are basically just giant, impossible mazes.
And these are just a few examples. Think about medicine. Figuring out how a complex drug molecule will work in the human body is like an impossibly huge maze for our computers today. But a quantum computer could explore all those potential interactions at once, designing life-saving medicines in a tiny fraction of the time. It could also optimize traffic flow for an entire country, create uncrackable online security, or build climate models that predict weather with stunning accuracy.
Now hold on, this doesn't mean your next smartphone is going to be a quantum computer. So don't throw yours out just yet. These are highly specialized, incredibly complex machines built for very specific, very hard problems. Your phone is still the undisputed champion of sending texts and watching cat videos.
So while this technology is definitely still in its early days, the potential is just staggering. We are standing at the very beginning of a completely new age of computing.
And really, that's the most exciting question, isn't it? The very first computers filled entire rooms just to do basic math. Nobody back then could have possibly dreamed they'd lead to the smartphones we all carry in our pockets. Quantum computing is at that same room-sized stage right now. It has the power to solve problems we currently think are unsolvable and to change our world in ways we can't even begin to imagine.